If you like science but don't have time to read studies, subscribe. We're glad you're here. Consider the following. There are 47,000 galaxies in our local supercluster. Multiply that by 2 million, and that's how many galaxies are in the observable universe. But which ones contain life? And how do we find out without sending probes to each galaxy? The emerging field of astrobiology attempts to answer these questions. A new paper from the University of Belgrade explains there are 4 things astronomers should consider when hunting for life outside of the Milky Way. Number 1. Age. Galaxies need to be of a certain age to be habitable. Planets lying within individual star systems need to exist for a long enough time for life to develop. There were no galaxies in the very early universe, and therefore no life, we think. The first stars formed 200 million years after the Big Bang and eventually created the first elements necessary for life. But even then, far more time would have to pass for it to arise. This presents a problem for astrobiologists. The speed of light limits how deep into the universe they can search. Consider an extraterrestrial studying us. They'd have to be within 5,000 light-years of our planet to see any evidence of human civilization. This is because if they were exactly 5,000 light-years away, it would take light from the Earth 5,000 years to reach them. The light they'd see was created 5,000 years earlier. An ET further than 5 million light-years away would not see any homonyms at all. Beyond 540 million light-years, and they wouldn't be able to detect biosignatures of multicellular animals. And past 4.5 billion light-years, they wouldn't be able to detect the formation of Earth yet. When we look out at the galaxies beyond ours, we aren't able to detect any recent biological signatures due to the speed limit of light. With that said, our local supercluster is 250 million light-years across. So we still have a nice large sample of nearby galaxies to analyze. Number 2. Metallicity. This is a measure of how many heavy elements an area in space contains. To build a planet, there generally needs to be things like iron, silicon, and magnesium. It was long thought that high metallicity was needed especially for rocky planets to form. Recent discoveries have weakened this assumption though. We found rocky exoplanets near metal-poor stars we didn't expect to see. Scientists now think large gas giants need high metallicity more than rocky planets do. But there's one reason why this still matters in our search for life. Gas giants protect their smaller companions from impacts. Jupiter acts as a shield for Earth by attracting comets and asteroids. When searching for life in nearby galaxies, we should look for spots where gas giants and rocky planets form. Number 3. Low rates of stellar explosions. This is a subject that isn't well understood, but generally, we think sources of ionizing radiation from stellar explosions can sterilize planets. These sources include supernova from massive stars, gamma-ray bursts from the formation of black holes, and even strange starquakes from neutron stars. When this radiation hits a planet, it can destroy its ozone layer, acidify its oceans, and cause cancers in organisms living on the surface. The megalodon, the biggest shark to exist on Earth, was made extinct by a supernova 2 million years ago, scientists now think. Radiation caused cancerous mutations in the animal. On a galactic scale, we generally want to find places that have low rates of stellar explosions. Number 4. Proximity to galactic center. It's harder, if not impossible, for life to exist close to a galaxy center for 2 main reasons. First, most galaxies are thought to contain supermassive black holes. These enormous objects periodically swallow matter and emit energy in all parts of the electromagnetic spectrum. All planets within 3,000 light-years of a central black hole are stripped of their atmospheres when they become active. The other reason is simpler. Star systems are also closer to one another near the center of galaxies. This increases the chance of close passes between stars that affect the orbits of their planets. Changes in a planet's orbit would affect temperatures and potentially exterminate life. In 2018, scientists discovered a rogue star, Gliese 710, will pass our Sun at 100 times the distance to Pluto. This will happen in about 1 million years. Thankfully, it's not close enough to affect Earth's orbit. Stars need to pass under 2 to 3 times the distance of Pluto to truly disrupt planetary orbits, and that's more likely to occur near the center of galaxies. The scientists think much more research needs to be done. We still don't know if life exists elsewhere in our solar system, let alone other stars in our own galaxy. But their paper can be a guide to future astrobiologists as they look outside the Milky Way.